Hello everyone. In the last class we have studied greedy technique and one example with the greedy technique, that is coin change problem. And this is the next technique in greedy technique, next problem type in the greedy technique, that is knapsack problem. This is very important in your greedy technique. Okay, first we should know what do you mean by a knapsack problem. Here knapsack is nothing but a bag or a container. What is this knapsack problem actually? Here in this knapsack problem you will be providing with the weights. First we will be having a maximum capacity, that is indicated by M. M is the maximum capacity. Okay, and then you will be having one container. For this one you can fill the weights. Here for example I'll just take the maximum capacity of this bag is 30 and I'll just take some weights and along with the profit. Here I'm not considering only the weights, along with weight you have to consider the profit, so that you have to get the maximum profit on filling the weights into this bag. Okay, I'll be having some weights like 5, profit is 10, then 10, profit is 7, then here it is 20, then profit is again 10, then it is some 15, and then profit is 6, 10, profit is 15. Likewise we'll be having something. Here you have to just fill these weights into the bag. But what is the maximum capacity M? That is 30. But here if you count, you will get more than 30. You have to decide how you have to fill these weights inside the bags so that you have to get the maximum profit. Okay, here you can have some methods. See, first I can just select the profit which is having maximum profit, that I can select and I can put it inside the bag. See here 15 is the maximum profit, next 10, 10. Then 7, then 6, like this. Or else you can select with the minimum weight so that you can fill minimum more values and then more profit. But apart from these two methods, we have one more method. You have to just take the ratio of profit and weight. P divided by W, that is PI divided by W. Then you can just arrange this in decreasing order and then you have to get some weight. Means you have to get the order in which you have to just place all these weights inside the bag. That is your knapsack problem. Okay, now let me see the algorithm for this knapsack problem. See, algorithm, greedy knapsack, M, N, W and then X. What is M? M is the maximum capacity of the knapsack, and then what is N? N is the number of objects you can fill, and W is the weight, and X is the solution vector. See, I'll just start over here, and you must know RC. RC means it is remaining capacity. What is this remaining capacity? See, for example, I'll fill the weight 5 into the bag. Okay, now what is the maximum capacity? 30 is the maximum capacity. Already I have filled 5, means here 30 minus 5, this is 25. This is the remaining capacity. Then I'll fill 10. What is the remaining capacity? 15. Now you can have 15 kgs. Here 20 is there. You cannot just select this one. You have to divide this and then you have to think. And then I'll go for this one, 15. Yes, directly I can fill 15. What is the remaining capacity? It is 0. Until remaining capacity becomes 0, you have to just continue with these steps. Okay, let me see the algorithm for that now. For I is equals to 1 to n. That is, it will start from 1 till n. X of I is equals to 0. Initially the solution vector X will be not having anything, it is 0. Okay, next, what is the remaining capacity? The maximum capacity will be equal to remaining capacity in the beginning. Here 30 is the M, that is maximum capacity. In the beginning we have not filled anything into the bag, means remaining capacity is equals to your maximum capacity. Now I'll start. For I is equals to 1 to n. If W of I greater than remaining capacity. See here, remaining capacity is 30. For example, here the weight itself is 45. Is 45 greater than 30? Yes, the condition is true. Weight is greater than the capacity. Then you have to break. You should not select that one. Okay. And then put x of I is equals to 1. That is, you have just gone through this weight. If this is not the case, if W of I is not greater than your remaining capacity, then what you have to do, you have to, if W of I is not greater than remaining capacity, see here 10 is 10 greater than 30, no, the condition is false, then you have to set the solution is equals to 1 and you have to find out the new remaining capacity as I have done here. Okay, yes, if this is true, if W of I greater than remaining capacity, then what you have to do, you have to come over here. If I is less than equal to n, then you have to calculate how much part of that weight should be included in the solution. That is, remaining capacity is 30 divided by 45 you have to do. Some part, for example, some 60% of this has to be filled into the bag. Then only that 60% should be filled inside the bag. That is this x of I is equals to RC divided by WI. If I go for the problem, then you'll understand this one. Okay, now let me go for the problem. See, find an optimal solution to the knapsack instance. What do you mean by the optimal solution here? To find out the maximum profit is the optimal solution in this knapsack problem. Instance n is equals to 7. That is, what is n? N is the number of objects. M is equals to 15. M is the maximum capacity. Here I have just told you profit and weight will be given. Is it not? See, profit n is equals to 7. There will be total n objects, 7 objects. So 7 profits will be given. 10 to 3. Then 7 corresponding weights from 2, 3, 5, 7, 1, 4, 1. Okay. I have just told you, you have to follow the rule in order to get this one. To get the optimal solution, first you must arrange objects in decreasing order. How will you just arrange this objects in decreasing order? Actually, we have a method, that is Pi divided by Wi. What is the Pi divided by Wi? You have to just divide your profit and the weight, and then you have to get it done. See, first one, I'll take P1 divided by W1. What is profit 1? It is 10, and profit, the weight 1 is 2. So I'll just take it as 10 divided by 2, that is equal to 5. Okay, next in the same way for all the profits and weight, P2 is equal divided by W2, that is 5 divided by 3, that is equals to 1.67. This is P1, this is P2, then P3 divided by W3. What is P3 and W3? It is 15 and 5, that is 3. Then P4 divided by W5. P4 is 7 and W5 is 7, that is equal to 1. Don't get confused, I am taking from here. See, P1, W1, P2, W2, P3, W3, P4, W4, P5, W5. P4 and W4, 7 divided by 7 is equals to 1. Next, P5, W5. What is P5, W5? P5 is 6, W5 is 1. This is 6. Next, P6, W6. That is 18 divided by 4. That is 4.5. And last, P7 divided by W7. That is 3 divided by 1 is equals to 3. I have told you, to get optimal solution, arrange the objects in decreasing order. Decreasing order. First you have to select the largest one. Which is the largest one among these? It is 6. 6 greater than next largest is 5. Then it is 4.5. Then it is 3, again it is 3, then 1.67, then 1. Now we have to form a new table. Objects, weight, profit. How many objects are there? 3, 4, 5, 6 and then 7. Now weight and profit, how you have to take? 6. What is 6 here? Profit 5 and weight 5. This has to come first. Weight is 1, profit is 6. Next 5. Profit is 10 and weight is 2. Weight 2, profit 10. Next is 4.5. That is weight is 4 and profit is 18. 4. What you have to take? First this is the P3 and then P7. So I'll just take this one first. 5 and 15, then 1 and 3. Next 1.67. With this weight is 3 and profit is 5. Last this is 7 and 7. Now this is how we'll just write the table. With the help of this one, now we'll proceed for the algorithm. That is how to calculate the maximum profit using your knapsack algorithm. See, this is the table what we have to take. Objects 1, 2, 3, 4, 5, 6. Sorry, here first you should not take any objects. 1, 2, 3, 4, 5, 6 and then 7. I'll just tell you why I am not taking this first row. What is the first step? Here solution will be equal to 0. First you have to initialize the remaining capacity. Okay, in this table also I am not filling all these things. First I'll reinitialize remaining capacity. RC, in question what they have given, M is equals to 15. So RC is equals to M, that is remaining capacity is equals to 15. Next I'll start with the first object. Object 1. Yes, object 1. What is weight? 1 and profit is 6. Weight is 1, profit is 6. Okay, how you will just update this one? You have to just check whether weight is greater than remaining capacity. Weight is 1 and remaining capacity is 15. Is 1 greater than 15? No, the condition is false. So you have to put it as x is equals to 1. Then profit is equals to x into profit. That is P is equals to x is what? 1 into profit is 6. That is equals to 6. Okay. Next remaining capacity. It is what? 15 minus 1. That is remaining capacity is 15 minus weight I have filled into the bag now is 1 and x value 1. 15 minus 1 is equals to 14. Now remaining capacity is 14. 14 units you can still fill into the bag. Next you have to take the second object. Weight is 2, profit is 10. Weight is 2, profit is 10. Is 2 greater than 14? No, the condition is false. Again x is equals to 1. Then 1 into 10 is equals to 10. Okay. Then here remaining capacity, it is RC is now 14 minus W is 2. We have taken 2 into here x is 1. 14 minus 2 is what? It is 12. Okay. Next third weight you have to take 4 and then 18. This is 4 and 18. Is 4 greater than 12? No, the condition is false. Again x is equals to 1. Then 1 into 18 is equals to 18. Yes. Next, what is the remaining capacity? Here it is 12 minus, what is this? W 4 into 1. 12 minus 4 is 8. 8 is the remaining capacity. Next 4. 5 and 15. This is 5 and 15. Is 5 greater than 8? No. So again x is equals to 1. Then 1 into 15 is equals to 15. Then what is remaining capacity? 8 minus 5 into 1. 8 minus 5 is 3. Okay, I'll go for the next object, fifth object, 1 and 3. 1 and 3. Is 1 greater than 3? No. So x is equals to 1. So 1 into 3 is equals to 3. What is the remaining capacity? 3 minus 1 into 1, that is 2. I'll go for the sixth object. It is 3. Profit is 5. 3 and 5. Okay. Now you check, is 3 greater than 2? Condition is true. See here, if W of I greater than remaining capacity break, then you have to come over here. What is the I value? You have to just check if I less than equal to n. Yes. Is 6 less than equal to 7? The condition is true. You have to do RC divided by W of I. So here I'll do RC divided by W of I. RC is what? 2. Weight is what? 3. That is equals to 0.67. So you have to take 0.67 into 5. The value is 3.35. Why I have to do like this means the remaining capacity is 2, weight is 3. I cannot just fill this 3 inside the bag. You have to just check how much percent of this 3 can be put inside the bag. That is 67% of this can be put inside the bag. Okay, so remaining capacity is 2. Then Wi is what? You have taken 3 into x value is 0.67. You will get 0. Still one more object is there, but here remaining capacity reaches 0. So you cannot just take this one. 7 and 7 I'll write, but this is 0. I cannot take this because remaining capacity reaches 0 means you have to stop doing this one. Okay, this is the knapsack. Now you have to find out the profits. What are all the profits you have here? 6 plus 10 plus 18 plus 15 plus 3 plus 3.35. What is the total? It is 55.35. This is the maximum profit and this is the optimal solution what we have got. And you have to find out the fractions also. Fraction and then weight. Fraction I'll take x1, x2 till x7. These are all the fractions. 1 till x5 it is 1. x6 it is 0.67. x7 it is 0. And then what are the weights you have taken? 1, 2, 1, 3, 7. This is your knapsack problem. This is very, very, very important. Okay, and at the same time, as next method, I'll just come up with the next video. Okay, thank you.